Welcome. Let's take a look at lesson 11.6, which is hypothesis testing. But before we do so, let's kind of review what we just learned about with confidence intervals. Number one, a random sample of 300 airline passengers show that the average travel time to their destination was 3.45 hours. Assume that the standard deviation for the previous studies was 1.15 hours. Find the maximum error of estimate given a 99% confidence level. Then create confidence intervals for the mean travel time of all airline passengers. So what I'm going to do is I'm going to go over to our statistics calculator that I've created. We're going to go to confidence intervals and type in our information. We know the mean or assumed mean is 3.45 hours. The standard deviation was 1.15 hours. We want a 99% confidence level, which means alpha is 1 minus that 99%, which would mean 0.01. Now, so here's how I'm getting this. The alpha is always 1 minus that confidence level amount, which is 99%. So you subtract from 1 or 100%, 99%, and we get 1%, which is the same thing as 0.01. So that's my A here. And so let's see here, number of samples. We weren't given any certain number of samples here unless, oh no, here we are, 300. So we're looking at 300. I'll scroll down here. There's my maximum error. It's 0.17. So it looks like B is going to be the correct answer. And if I wanted to see the picture here, don't I have a picture? I guess I don't. The confidence interval would span from 3.28 to 3.62. 3.28 to 3.62. So it is correct. B is the correct answer here. And you can go back through and look at the formulas, how we come up with this. But for the maximum error, if you're dealing with more than 30 samples, you'd be using the normal distribution. You would take your Z score value that we get from the quantile function divided by the standard deviation of 1.15, excuse me, times that standard deviation divided by the square root of the samples, which would be square root of 300 there. So the Z value for the 99th percentile multiplied times 1.15 divided by the square root of 300. And that's how we got that 0.17 right there. Okay, and number two, in a random sample, let me explain some of this too. What we're saying is we can say with 99% confidence that the true mean is somewhere between 3.28 and 3.62. All right, so that might have been the samples mean. We can say the true mean, if we expand all the way out with 99% confidence, would be between those two numbers. Number two, here a random sample of 20 high school seniors. The average time spent watching television each week was 8.7 hours, with a standard deviation of 2.4 hours. Estimate the mean number of hours spent watching television for all high school seniors using a 90% confidence level. Okay, so here we go. This time I'm dealing with 20, which would mean I'm not going to use the Z-score value or the normal distribution. I would use the T distribution because I'm less than 30. The mean here was 8.7, I believe, 8.7 hours with a standard deviation of 2.4. So given this information, the maximum error is going to be calculated using the T-score value, if you will. The 99, oh wait, I'm at 99 percentile. We need to go to 90. Let me change this. Let's change your number. So I go to alpha, and I'm going to say 90 percentile is 0.10 or 0.1. The way we would get that is we would say alpha here would equal 1 minus 90%, which is 10%, or you can rewrite that. And like I was saying, A would be equal to, come on now, 0.1 or 0.10. So that's my alpha there. And when I come down, my T-score value for the 99th percentile would multiply with the standard deviation of 2.4, and then you would divide by the square root of 20. And we'd get this 0.93 if I round. So 0.93 is the maximum error, and the confidence interval would go from that 8.7 minus 0.93 and plus 0.93 to get those two values, which looks like to me 0.77 and then 9.63 would be, the correct answer would be A here for number two.